Hey everyone! Thank you for joining us for another episode of the Build AI Apps with Azure Database for PostgreSQL series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our hosts and speakers to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over for our speakers for today. Thanks so much for joining.
Hello, everybody. Welcome to this third and fourth part series for Build AI Apps with Azure Database for Postgres. Today, we're going to be talking about building your own AI Copilot for financial apps with Postgres. So my name is Wislang. I'm a cloud advocate on the Cloud Native and Linux advocacy team at Microsoft. I work between open source compute and open source data like Postgres. And I'm here with Ismael Mejia, who is a senior cloud advocate on the data team inside of advocacy. Hello, Ismael.
Hey, hi. Thanks for the introduction. Well, I work also in all things data now. It's my area of coverage. Like I say, everything from little to big data, fabric, whatever. Bring it.
Fantastic. Great to have you here. So today, tell us a little bit about what you'll be showing us through today.
Yeah, okay. Today, this is the third episode, and we are going to cover like a more realistic use case, let's say. Like so far, we did, first episode was about, well, the general concepts of AI plus Postgres. Second episode was more about the Visual Studio Code extension and all the cool things you can do with the agent mode. And well, this episode is more like a concrete example. We are going to use a lot of AI services, but I will go deeper in a minute.
Fantastic.
Okay, so just can you move to the next slide, maybe, just Aaron?
Yes, apologies there.
Yeah, just a reminder to people who may be joining this today that this complete series is still ongoing. You can catch up the whole episode. You can register in this URL, this address. You can see, well, the next episode also on Thursday, which is going to be another real-life application using AI plus Postgres. And just the next one, and then we switch maybe. Yeah, this one is, well, this is, as I mentioned, this is the third episode. We are building a Copilot for financial apps, but well, it's not necessarily financial apps. It's in the context of a financial company, but it's more like to, let's say, validate contracts and invoices. And the next episode, next week, well, it's going to be about a more advanced Copilot, but for legal cases. But let's go now. We can switch to my slides, maybe. Thank you. Okay, so well, what we're going to build today is a kind of a common use case where we have to do things manually. So if we are a company, let's say, well, sometimes we have contracts that we want to, let's say, have with people. So they create statements of work when they propose like some prices for things they're going to do, and then, well, if we accept those, then we get invoices from them for each of the steps that we are doing. And finally, well, we have to match those. And this is a kind of a scenario that usually is manual, where somebody receives a Word document or a PDF, because, well, so it cannot be changed with the numbers, and you have to extract information from them. And that's something that, well, usually somebody does manually and checks the values and gets the validation done. What we are going to do today is going to show how to do it automatically, let's say, or the more automatic that we can using AI. So, well, what are the goals today? Well, we are going to see how to use generative AI with your data. So all this text of the documents, we are going to cut it into pieces, let's say chunks, as we call them. And then we are going to use, well, generative AI to analyze this using natural language. Of course, we are going to use Azure AI services for all of these, from extracting the information from the documents to validating the documents themselves using OpenAI. And then, well, once we have this working, another thing we want to do, well, is have the interactive chat to discuss with this with our data. No, we want to know, for example, which invoices belong to which vendor or stuff like that. We want to ask these questions using natural language, so we are going to build this solution too. And when we have these responses, one of the most difficult part once we have a chat like using RAG system is, well, to improve its accuracy. So we are going to use a semantic ranker. We're going to show you how to use GraphRAG. There's a lot of content today, so I hope we can go through it. Well, let's continue. If you want to follow along, I don't know if this already was shared, the link. Well, we have two links for this. One that goes straight to the GitHub repo with the code, another who goes to the documentation. Today, I mostly will go in three ways. We go through the documentation. Maybe I will jump back to the slides for some concepts, and then we go back again back to Visual Studio Code to see the things in action. So that's how we're going to do. But first, let's introduce our architecture, and maybe this is a little bit overwhelmingly complex, but it's not so much. So what's the idea? The idea is that we receive these statements of work that are these proposals, with the work that somebody is going to do for our company, and we receive also invoices. All of these come through our web service, and then we're going to analyze, we're going to validate this data, taking the info from the PDF themselves and extracting them into our database. So once we have them in the database, we're going to do a validation process also, where we match values and we have some rules that we define. And what is pretty cool is that these rules are defined with natural language. So this is maybe if somebody has experience in the past when we did this sort of rule, we have to write all of those rules in code, like with ifs or even create more complex systems like read algorithms or things like that when there are too many rules. But well, today what we're going to do is put those rules in a prompt in natural language, and well, we will see how it processes and get the results.
So I noticed you called this is called a solution accelerator. It looks like it's very generic and broadly applicable, so that other people could take and build on top of this, right?
Oh yeah, absolutely. I forgot to mention that this is based in a solution accelerator. We are with the Postgres team at Microsoft, the Azure database for Postgres team at Microsoft, have built many, at least 3 or 4 that I'm aware of, solutions accelerators who are like ready-to-use solutions that you can deploy with 2 commands into the Azure cloud, check that how is built the application with all the details, and they cover different cases. This week, we are covering 2 of those, and well, this is the first one. Yeah, good call out. So going back to this point, well, we have this first part when we're validating the documents, and the second part in the lower end is when we create this kind of RAG chat solution with our data. We are going to do this using multiple Azure AI services, but also using LangChain, which is this framework to create AI apps. We will see that in the code. Obviously, it's too much content to go into the details of everything, so I just maybe explain the basic concepts of everything, and well, I hope you can continue on your own afterwards. Okay, so let's start with what happens. What is the data flow here? So we receive a document, through a browser application. You upload your PDF. It gets into our API, which we have an API written in Python. When I mean API, I mean REST API. And these documents are stored in a blob storage. Once they are stored in the blob storage, what we're going to do now is to extract the information from the documents. And to do this, we are going to use the document intelligence service that is part of the Azure AI services. When we get this document divided, and it's a good thing, maybe I'm going to jump a little bit to look at one of the documents so it makes sense, the explanation. For example, this is one of the statements of work. So I'm going to maybe zoom this a little bit. As you can see, well, we have the project, we have more information, like the dates, an assigned number, a scope, and then we have the objectives, what we want to achieve. We have the tasks, and these tasks usually map to items that will come in the invoice sometimes, and sometimes have an associated plan pricing. And we have schedules, of course, and this is important because when we are validating that let's say that the vendor did what it had to do, well, we have to check these dates, and we have this could be part of the rules. Like, for example, if this was not finished, if I have the invoice or something that has not been accomplished because of or that was late, well, there are some things that have to be paid, additional things now. And of course, well, all of these things we want to extract using document intelligence. The idea is to extract each section so they are together. And why we want to code this and not have the full thing? Well, to refine the analysis afterwards. So this is more or less what it looks as thing. As you can see, it's a pretty like Word-like document. So it's not nothing structured, no XML or JSON or whatever. And this is, I'm going to show also at the same time, one invoice. Well, this is like a common invoice with a number and the name of the provider and the different steps, the deliverables that were done, and on the price and the date, so we can cross those. Again, this is also going to be processed with this document analysis part. Just going back for a second to the slides. So we were here in the document intelligence part when we are going to do chunking and semantic chunking, let's call that. So because, well, we're going to do a chunking that is more intelligent, we will have these natural language superpowers there. And then, well, what we're going to do is we want to write all of this to our database. And, well, in the case of Azure database for Postgres, we will have these vector store that are going to be stored as columns in our database. Once those are there, we are going to go to this language service to do like a summary. We can build, for example, a summary from this long statement of Word document. We can write just a one paragraph summary to make easy for users to catch on the information. So I just showed, that was just what was next, how they look, the statements of work and the invoices. So we already saw that. And this is the actual deployment. So, well, let's jump now to the documentation of the lab, let's say, we can call it like that. So, well, I'm going to go quick here in the steps that I'm not going to cover. I'm not going to cover the initial steps of deployment because this is a little bit long and I don't want you to wait 20 minutes while this thing is deploying. So basically, we have some prerequisites. We need GitHub and a GitHub account because this is hosted in GitHub. We need Azure, of course, to deploy our infrastructure. All of this is done through Bicep, and of course, you need a computer. Probably it would be great if you could do this with the telephone, but well, it's not the case. I'm going to zoom a little bit more, maybe, so you can read more. Okay, this is just explaining what I explained, what is the use case, and especially the first part, and the objectives we have with this lab. So just jump into the next. Now, okay, so what we're going to do here is contract validation. That's what we're going to validate, that the statements of work match with the invoices. And well, what we want to do is using data validation with AI, and that's what our main goal at this first section. The second section is to build a copilot to interact with our data. Okay, so let's go next. Well, the application, the architecture I already explained for the first part. I will explain for the second part when we get there. Data flow, that's nothing new. This is a neat part that they put in the lab. This is like an estimated cost of processing the model. They're processing, all the things in this solution, like from the semantic ranker model that I have not spoken about, through the database service, app configuration, container registry, all the things that are inside. Will just so you are aware when you play with this how much it could cost depending on the services that you use. Okay, so yeah. Any comments? No. Don't hesitate to interrupt if there are questions or anything. Okay, so and if I'm going too fast, or if I'm going fast, but there's so much to cover that I fast. But look, let's go slower. Okay, we have the database. We have a database that represents these documents, and maybe that's the first time we are going to check out our Visual Studio Code. So let's go here. Now, I hope, and for those who are not, or you who are not familiar, well, we have now this Visual Studio Code extension for Postgres, which is done at Microsoft. And with this, we can query the schemas, but I'm kind of worried that maybe my session is already timed out. So I'm going to check, let's check the invoices maybe to see if it works.
So you've just cloned this down from the public repo. You've got everything that you need to be able to continue in here so people at home can follow along.
Absolutely. If you just copy, if you just clone the repo, or even you can just browse it with the Visual Studio Code mode in your browser when you press dot. You can check the same things, but well, you won't be able to check the databases I'm doing because I already set up a connection for that. That is not working, by the way.
So you've run the deployment command already, or is this?
Yeah, the deployment command is already written. Give me just a second. I'm trying to get the token. So because I'm configuring this manually because I had some issue with the authentication with the extension that I have to report to the PMs. And wait, so I have this. This is totally not secure, but well, we are going to kill this instance just ready after this. So please, if you're going to hack, do it like in 1 hour. Okay, let's run this. Okay, so we are connected now to the database. And yes, just to respond Aaron's question, yes, I run the ACD command. We have a full setup of ACD in this Azure Developer CLI tool with the full solution. And this is just to show a little bit of this. This is the full script that you can see in a second.
So this is all based in infrastructure bicep as code, which is deployed via the Azure Developer CLI. You just run AZD up, all the infrastructure comes up in your Azure account, and then you're basically good to go.
Exactly. I didn't do that because, well, this takes like 20, 25 minutes. So well, I don't want to wait all that long. And I also wanted to be able to have the database ready to show and everything. So, but yeah, if you're going to deploy this is where you do it. If by any chance you hit any issue there, don't hesitate to report in the GitHub repo because, well, configurations of people change and sometimes these things fail. So
just a brief question for people who are connecting. So after you've brought everything up for the firewall, are there any firewall rules or anything else to set up, or is it open temporarily to the public internet so that somebody can connect from their local machine?
Yeah, exactly. Is it right now? Is it open? But well, but what I'm going to develop is going to be mostly local, so yes. we won't see it right in the public instance. No.
Fantastic.
So okay, so here we are. So we have the. Oops, I'm crazy here. Give me a second. I'm a little bit lost because it's too zoomed. So okay, now. Okay, here we have the tables of our table model. And this is an interesting moment to switch, or maybe let's do something interesting. Like, okay, so I'm going to disconnect for a second, and I'm going to, oops, I'm going to connect, but I forgot how. Oh, yeah. Okay, no. Sorry, I have to go back here. I'm going to connect to the database with agent mode to try to see how it goes. So this is like a betting that everything will work. Okay, so with this agent mode, what we have is an interactive access to our database and its context. Now it's connected, it's showing all the information about database, and it's asking me what I would like to do. So I want to visualize the database schema. We're going to see if it works. Crossing fingers.
So for people who haven't seen this before, this is the brand new extension, the Visual Studio code extension for Postgres, which was launched last month, which has all of this new capability baked in, which supersedes the old extension.
Exactly. So it created the database schema graph. Well, it's a little bit hard to read there because it includes a lot of things, but of course we can zoom on those. Like this is the milestone of the project. These are the invoices table. So we can see all of this. Of course, well, I won't go right now into the detail here, but I just wanted to show this functionality, and I can ask queries in natural language here. But well, for the moment, I will just go out for a second from here. And we go back to the more traditional style. So let's take a look at the tables. Let's take a look, for example, at the statements of our tables. And then we have something like this. Check. So we have the IDs, the number, the vendor who produced the information here, the start date and date, the budget numbers. All of this was extracted from the documents. So we're going to see this in action in a while. But what I want to show you is more, and try to get you familiar with it. I know it's not so easy. Is sorry, I'm here. The fact that the relationships of the database, this looks a little bit bonkers, but the funny thing is that this was generated by Copilot. So also, when I asked the question and give me a database schema, I generated this with text code. So I put the photo just to capture
it generated the image for you with Copilot?
Yes, that's crazy. Yeah. So I let the image. I didn't do it because I was worried of the demo effect that I was going to break, but it was generated like this. And I was expecting it to generate the other schema like the one in the database, but like the one on the extension, you see the blue one I just showed, but it showed this one. Okay, so and this, as you can see, well, we have vendors who can produce statements of work or invoices. That's a quite common relationship. And these statements of work have milestones, and well, the invoices have items that are covered. Pretty simple, let's say, database with relations in multiple directions. So let's go back to to our explanation. Well, here they're explaining which is every table. I won't go into all the details of that. Well, we have some extra tables for the chat sessions that we are prepared in advance for the lab. So, and then there are some graph relations that we are going to see also later on. So I won't go more deep into the tables for the moment. Okay, back to the setup steps. Oops, I'm already late. Okay, so you need a subscription. You need to have access to Azure ML, so you can put our semantic ranker, but that's also something I'll cover later on. And well, as we mentioned before, well, one part is setting up the infrastructure. You do that using ACD app. But you also may need to set up your development environment. Same thing. I already did that locally. You can do this with the provided dev container that is part of the solution. You can build a dev container and work with it.
You also work in code spaces?
Exactly. It also, well, it should work on code spaces. I haven't tried, to be honest, but it should. Well, of course, this is dev containers. You need Docker to run these things, or at least a container solution, Docker-like, if you are like more purist. And also, well, you have you need, well, if you're to install the Azure CLI, the Azure Dev CLI, up to this. So, well, this is just the setup, the requirements, nothing extra to see. But something that you should not forget is that you should add the Azure ML extension as part of the Azure CLI. So you can do all the setup of the ML parts, because that's not part of the core Azure. Well, of course, you need Python, and I forgot to mention that. The architecture is in the API services are written in Python, and the front end is written in Node.js. So it's like a common, let's say, somehow.
So do I need Node.js installed as well for?
Yes, you need to install Node.js.
Node.js, Python, AZ CLI, and so forth. So we actually, if I could pause you for a second, Ismael, we have a first question from Shaheen. It says, how do you handle the mismatch between structured financial data like SQL tables and unstructured generative models when using LangChain or GraphRAG with Postgres?
Okay, so one thing we do now is, and we are going to see that in some minutes, is we try to give a structure to things. So you mentioned in that case that the structured data, well, is let's say financial data is structured, but well, you sometimes you don't have a clear structure, and that's the case in this scenario. Like you have the Word-like documents where you have to get the structure out. That's the first step we did. And well, what we care here and what is really important is that we are building a language solution, and that's something we should not forget. This is a natural language solution, so the more natural language we can transform into embeddings and stuff like that is the way the better we can relate this with the world LLMs through LangChain and all the other algorithms. Well, maybe when I show more in detail, well, probably this will answer the question we will see, and otherwise we can come back to that. Okay. Okay, so going back here, okay, so well, you have to fork the repo. If you want to have your own copy and well, fix the steps that you are supposed to fix while developing this. Of course, your deployment, you have to set up your Azure region, probably the closer to you. And then, well, you have to verify that you have the access to the quota, because sometimes, well, some people don't have access to this quota, which was the case for me when I started this demo. Okay, so that's basically it. I'm just going quick because I'm not running this, just showing you all the steps that are part of this. You have to authenticate with your session. You have to authenticate also your ACD. And then you do ACD app. This is the most key part. This is which is going to take like 20 minutes or more. And it sets up the full infrastructure. It will ask you some questions, and there's a good moment to present two things. Well, one is that as part of the second, let's say from the Copilot solution, we are going to use our own re-ranker, which is, let's say, a machine learning model that reorganizes the answers of a query to make them more accurate. It's all about improving accuracy. So we are going not to use only the capabilities of, let's say, a typical distance algorithm like the ones we use on AI. We are also going to use this kind of re-ranker solution. And as we are using this, we'll have to deploy it. So if you are deploying this on your own at home and you don't want to pay a lot, please choose the mini solution because that's probably cheaper. It's only for CPUs, so that's not so expensive. If you want a real life, like more hardcore, let's say, kind of re-ranker, well, you can use the BG. So yeah, and you can even not use any of those. You can also use the solution without any ranker, so you don't have to pay much. Okay, so but that's to show one really, let's say, realistic use case, because usually the solution, the answer from the LLM cannot be as good as when we have more context, and part of this context could be this re-ranking process. Part of this context could be this GraphRAG thing that we are also going to talk afterwards.
So the re-ranker's job is to provide exactly the right context to the LLM so that it can be more effective.
It's probably to organize the answers, so they are more accurate. So we are going to organize to have the better answers, because, well, there's really a lot of disappointment when we ask an AI something and it probably doesn't bring the right answer, or bring it like a third or fourth answer after the other. So we're trying to improve that.
So disappointment reducer.
Yes. Okay, so that's last thing. Once your deployment is done, you have to validate that everything is as defined. You can do this going through the portal, and I'm going to go here to my subscription. You can see if you click into Resource Visualizer, you should have a graph like this. This is too small, but well, we can see just in the list here in the overview. I don't know if it's readable. I hope so. So you can see we have multiple services. We have 2 container apps that are running our application. There are 2 containers, one for the front end, one for the back end, that are the web services. We have also, of course, this is registered in a container registry, and a part of this we have our managed identity service, and and we also have the Azure ML deployment, because we're going to use this extra endpoint. And we have our Azure OpenAI also configured. We have our database of Postgres, obviously, and a storage account. So we can say that everything went well, was successful, so we are good to go. Okay, so this, continue advancing. This is very quick. Now here's the list of the things you have to check. So it's the same. So now the first part, we are going to test that the AI, the API is working. So you can do this while checking all the steps are there. So I'm going just to go here just to check that everything is working.
So AZD has also taken our web services, and because these are containerized web services, it's built them, put them inside of the container registry, and then deployed them to Azure Container Apps.
Exactly. Everything is ready, and the URL is exposed. So once you are there, you can. Okay, so this is you access it working, but we are not seeing anything so far. Okay, we are here. We are double checking that the machine learning endpoints are working, and this is important because we have to configure those with the database afterwards. But that's after. Okay, you're gonna end up with this. This is the dev environment. As we mentioned, you need to install Python, so you need a Python environment for all the dependencies to libraries. Let's say you install those the classical way with pip install -r requirements. Then you have to, and this is very important. You have to create a .m file that should have some config variables. You have to, especially at the endpoint of your configuration service, and you may wonder how do you find that. All of this is detailed. Again, I'm not covering all of this because otherwise it will take like 2 hours more. And you configure your database also. But this is how to configure in pgadmin, because this lab was created just before we released the extension. So now we have to change that to be the new extension. Okay. So there we are. We have how to check. We review that everything's working. The application is running, and now we're going to check the application a little bit. So let me just see one more thing here. Okay. Let's go to the application. So here we have the vendors that are our providers. Let's say. Let's hope it loads. It takes a little bit of time.
Live demo, just for proof.
Yeah, be kind. Cross the fingers with me. Okay, so it takes a little bit. I don't know why. Okay, so here we have our vendors, and let's say we want to check one of those. So you just go to view, for example, this phone company. We will see. You can see the details, and you can see if it has associated statements of work. Oh, I have the bad luck of choosing just the right one who doesn't have one. Let's look at this Fabrica, maybe. Oh, another one who does not have one. Okay. So let's go this Lucerne thing. Okay, Lucerne publishing. And this one has one. Yeah, okay. So here we have the statement of work that is associated. And commonly in this application, you have to manually, like this one is already processed, but that's a good thing to know. You have to manually do a step-by-step validation. Yeah. So this validation was done manually. We're not going to do that, but we're going to check something. And going back to see if maybe I have one that is, because that one is already validated. That's what I'm moving ahead. I want to find one that is not. Okay, this one is good. Okay, this one, as you can see, has the normal data, and these steps, these validations were done manually, like step by step. So someone with the check and said like, okay, it passed all the things of the required compliance section, and they said, oh, I found this, all these steps are being manual, and what we want to do is to improve those. Okay, so let's go back a little bit here. I want to find where this starts, and please bear with me because I can't remember all the details. Oh yeah, okay, so I didn't show the invoices. The invoices is the same story. Let's say we can check an invoice and we can see if it's validated or no. Again, manually, they can be, for example, you have to have some conditions, so you have to validate those. So going back, so there are a sort of rules that we want in our validation. And these rules, well, we are usually run manual validation for those. Now we're going to do it automatically using an LLM. So, but to do this, we need, multiple things. First, we need to configure our tables to have support for vectors. We do this with the extensions, with the, and we are going to talk about 3 extensions here. We have the PG vector extension, that is a Postgres extension to support vectors and of course queries with vector distances in the database. Then we have the Azure AI extension that is here. That is an extension that is useful to access our AI services, including, of course, the OpenAI one, but also the one who's going to do the chunking, and the one and the other one, the one who does the summarization. And then we have this DiskANN extension that provides an improved vector to query. It's a quicker index, sorry, to do our queries. We are going there. Okay, so how do we do this? We have to install our extensions, and this is something I'm going to switch now for the Visual Studio Code slide. I have this. I'm going to close this one for the moment, and also this one. Okay, so I have these scripts that are like what we care about now. So first, we need to configure these the extensions we are going to use, as I mentioned, the Azure AI, Vector, DiskANN, and also we have 2 more that are for the second part, that is the Apache H extension, and that is to support graphs in our database, and the Azure Storage extension that is to support data that is stored in Azure Storage into our solution too. Okay, so this is the first step. We run this. One thing that okay, so you have to set the parameters like following this path. It's really critical that if you are doing this on your own, that don't forget. I don't know why this is put like this, but you have to run each of these tabs. Somehow they are not together. I just put them together to explain it more easily. But not forget that if you see this, usually means you have to do all of them, not only one. So okay. So okay, you configure the Azure AI extension, and to configure the extensions, and this is a moment for a really interesting explanation. Like like sometimes developers are not used to access AI services directly from the database. And that's exactly what we are going to do this. So you may wonder why I'm doing this. Well, first, because you can, but second, because it makes sense. And this example shows why it makes sense. Because you want to enrich your data with this information. You want to transform the descriptions of your products, for example, make them vectors, and you don't need to create a full application for that. You just can use a query, and with the query fill all the data in your tables. So So how do you configure access to the services? Well, we have this Azure AI extension that I mentioned, and then it has different services for the scoring endpoint. You have to put the endpoint and the key. Of course, you find those going through your to the ML service. It's the classical. Well, you go into and you get the path, for example, the REST endpoint, and then you get the primary key, and then you can access those. You need to configure that for all the three services. Just going back to my scripts here. So you need to do it for OpenAI because we are going to generate the embeddings with that, to the Azure Cognitive endpoint because we needed to do the transcription and the chunking process, and for the scoring endpoint, that is the one we deploy for the semantic re-ranker. So that's all of it. You can validate that you put the correct information doing this kind of query. So yeah, okay. So that's for it. Then you have to include, as I mentioned, the PG vector extension is what we use to save the vectors, the AI vectors in our tables. So what we're going to do now is just to add columns to store those vectors. So if our table, for example, has some description or some textual information, in our case, this textual information is the tracks that we got from the statements of Word document. So these kind of sections could be part of that in the model we are using. So we are going to alter our existing tables to add this embedding vector. Again, you have to run the four of them. Just going back to here. As you can see, I have all of those. Again, I'm also adding all the ones I need here. You just have to run those. Okay. So now we are getting now into another issue, is that, well, once you have your vectors and you need to do queries, well, using just similarity search every time is a little bit slow. So we recommend to use indexes for that. And this is a moment to I'm going to jump a little bit to the slides because I want to show something. And I also missed many of the slides. I'm just going to go quick because there are so many. Okay, so just a little explanation for those who are not familiar. What you usually do with vectors is just take the raw data in natural language, we pass those through an embedding model that is available, and we produce vectors with, well, floats, not these complete numbers, and then we save those in the database. That's what we're trying to do. And how we do it is like it shows in this slide. We use, from the database, we use the Azure OpenAI extension. We say create embeddings. We take, for example, the description of the table, and we save those. This is how it works. And okay, just want to mention, but we have this native search. And okay, so this is a little moment to stop for one thing. There are two problems we want to tackle in every, let's say, AI kind of solution. One is how to make it faster, like for the answers, let's say. So one is how we scale these results querying, and this is using indexes. That's the index we were talking about just before. And the second one is how to make the solution more accurate, and that's what we also mentioned with GraphRAG and the semantic re-rankers improvements. So if you look at the literature or you look at other examples outside of the Microsoft sphere, you will see that most people use one of those indexes, especially this HNSW index, to calculate the distance between the vectors and have the answers to the queries on the embeddings. But we at Microsoft developed this thing called DiskANN, that is an optimized type of index. This is open source. If somebody wants to check, the code is outside, it's open. And of course, all of our databases support this, not only Postgres, but you can also use this in Cosmos DB or on Azure SQL. But, well, we are going to use this in this example for Postgres. So, okay, so going back here. Okay, here we are. So we are going to create the indexes. This is the explanation, the three types of indexes. And well, these are the operations we can do. We can do the cosine distance, well, for those a little bit familiar. Sorry, this is like kind of semi-advanced explanation because I didn't go into the details. So, okay. So once you have data, for example, in your statement of work chunks that were already caught, well, you can save those vectors. But if you want to improve the querying of those vectors, you need to create an index. And again, same story here. You have to create the index for each one of those steps. And go back to to my Visual Studio Code side. Oops, sorry, that was unintended. Okay. Yeah, that's what I wanted to do. Okay, so as you see, well, we created the embeddings, and now we are going to create the indexes for those embeddings. And well, we can check if the embeddings are working. So I'm not going to do that right now. We are going back here. Okay. So
we have a brief question, Ismael.
Yeah.
Somebody here has asked, are the keys stored in the database tables or as environment variables in the key vault? And I thought I'd jump in here and mention that the keys, when you provide something for Azure AI Foundry or a similar service, they are stored inside the database, but they are protected by a special role called the Azure AI Settings Manager. So they're not just accessible to everyone. And we have a link which describes that in Microsoft Learn as well, which we'll drop in the chat.
Excellent, because I didn't know the answer, so you helped me with that one. Okay, so let's continue. So as I showed in the previous slide, when we create embeddings using this OpenAI create embeddings function, let's say, inside of the database, we pass the text and we created the vectorized version, no? O sea, the vector, let's say. Okay, let's run this query maybe so we can see something. Oh no. And let's see if it works. And there we are. So this is, we are just testing how to create an embedding. We are just taking the ID and producing some data. Just testing that everything works. Okay, so here we are, same results. And now another, this is how we are going to, since we already have the tables with the descriptions, for example, what we want now is to update the tables. We created the column, we added the index, but now we want to update the information because so otherwise it would be null, no information. There were no vectors inside. So this is an update instruction to do this. And usually what we do is to create a trigger to do this. Why to create a trigger? Because every time you get you do an insert and you are going to save this new content inside of your column, well, we can automatically calculate the embeddings if you do an insert or an update, and you don't have to take care of that manually or do more things in other side. This is delegating the responsibility to the database. That's, I mean, people who love that, people who don't. I mean, I use the most of the database when I can, so. So
as a developer, it means I don't have to think about it, right?
Exactly. And this is, well, people who maintain the data are the people who maintain the data. Sometimes there are different teams, sometimes it's you, so it's in both sides. So okay, so now we're going to the most important part, let's say, to this AI-driven validation, and you will wonder how we're going to validate the documents. I mentioned before that we use document intelligence to chunk the data, to extract the data. So we have this, we said that we upload the documents through this document path, and then we have this, this service who's going to break those and extract the text. We call those structural element-based chunking. And you may wonder, well, that sounds really fancy, but well, if you see, these documents have like a sort of a structure that is evident, even if this is not a JSON or a XML. You know, you see the scope, you have the objectives, you have the tasks. So we can code those, and the algorithm does it itself. You know, the machine learning model that is behind this Azure AI service, it will do that for us. Okay, so what is the
does that work for
idea?
extracting tables as well, so it understands tabular structure as well as different sections and all of that kind of thing?
Yes, it does. You know, when we have the invoices, this is exactly what it does. You know, it understands each step of the milestones becomes an item of the invoices. So this is done like that. Yeah. And of course, this is an independent service that well, you have to set up and pay, but well, you pay once when you use it, you know, so it's not something always running. Okay, so what's the deal here? I think I'm kind of short, so I'm gonna go a little bit quick. So okay, so the idea is, as you saw, we have like logical sections that is going to identify, is going to And we defined the chunking strategy for all of this. Okay, so I'm just going quick because I don't want to go deep into this side, but just to show you, we define a table for the chunks that is going to be related to the statements of work in this case.
Are these snippets in the repo as well, or are they only in the instruction?
Yeah, absolutely. All of this is in the repo. Everything is accessible. Yeah. And okay, so as I mentioned, well, we also have the embeddings for the full documents, because it's always good to have also the full version a part of the chunks. I mean, it's not so expensive to store vectors, so that's not a problem, I suppose. Okay, so this is the function that is doing the actual extraction. Just I won't go deep into this because this is not well, let's say Postgres related, but you can check at this. It's basically accessing the Azure analysis client and putting these kind of sections that we identified before. If we know the documents, we know that these kind of sections exist, like the scope, and so it will code those and give me those chunks, and that's what we extract. Okay. So, and then these extracted sections will go and be stored in the database in the statement of work chunks table, and the same we do for the invoices. Sorry.
So I have a follow-up question here, Ismael.
Of course.
Can multiple documents be compared for differences, such as in the case of a version, or is the search limited to a single document?
No, I mean, well, at the moment, this solution does not support versioning, like the concept of. But I think this can be improved easily. I mean, well, with some hacks, but with AI, you could do it. But let me just double check that I'm answering the right question. You can compare for difference if you do your own solution, of course. I mean, like you put two documents and ask the machine learning model, like the AI model, hey, can you please find what is different, and maybe it will come with something accurate.
So you could extract the data and then extend one of the services, and it could provide that sort of within the solution.
Exactly. And the solution is honestly it's pretty well built, so you can easily extend it. Okay, other thing we can do here is to summarize the, for example, this long document. I mentioned that you maybe want to have just a paragraph that explains what it does. So this is what we're doing here. So okay, so this is how it goes, and as you can see, we're creating the embeddings, and with the embeddings we are creating a summary also. Okay, so just going to go a little bit quick because I'm seeing that it's quite late, sorry. Okay, this is finally the most interesting part, how we validate the data with OpenAI. And in this accelerator, what we have is a validation that is triggered by the arrival of an invoice, for example. And we created a prompt for that. And if we're going to go to the code, there is this okay, so we are going to go to validation. I hope it's this one. No, it's not this one. Okay, let me just go this way. I'm probably faster. No. Okay, so what we do is that we have an endpoint where we are going to do the validations, and what is pretty neat from my point of view, at least, is that these validations are done through prompts, let's say. So I'm trying to find where was this. Well, I think I have it open already. Yeah. Okay. For example, if you want to validate the statement of work document, what we're going to do is to run the function, let's say the LLM. We're going to give it this context, that this is the system prompt that we're going to use. So look, you are intelligent copilot for the bank, you're validating this, and you have these conditions. When you validate a statement of work, you should verify that the number matches the vendor records, so the ID of the vendor, check that the total amount is correct, ensure that the milestone delivery dates are before. All these conditions that usually were like ifs, that a business user couldn't do, well, now we can do it then with natural language. And of course, well, we can tell him also how to answer, provide a statement of valid, invalid for the statement of work, create separate sections for this, create a detailed summary for the results, and at the end, put passed or failed. As you see, this is the full system prompt. And what for me is impressive is that these conditions can evolve really easily, just changing the prompt, that you don't need like some extra development or blah, blah, blah. Well, you just need to change the natural language text.
Follow-up question here from Oleg. He says, how can you resolve the concurrency and avoid an overdraft, for example? And I just thought I'd highlight that in this pipeline, as I understand it, we're working with the documents and the validation, and your service and your API and the database itself would handle any transactions and overdrafts and that side of things. Would that be correct?
Exactly. That's how we do it. I mean, we are in a, let's say, not forget that this is a relational database, so we can block at will. So yeah, that would be the way to do it. Okay, so back to, I think it was here, then I was, So we have the system prompt, and we have the condition that I was just checking. So these were for the invoice. So those are the conditions, and you can see the invoice also has its own rules. So you have to verify different things. All this, other thing that's interesting is that this is a human, let's say, would follow those steps, but usually they are not even documented, like they know what you have to check, but really sometimes you just do, now you can follow along, even if you have to double check this, because, well, as you know, the AI can hallucinate, and that don't forget that you have to still double check, but at least this will accelerate things a lot.
And once you define your steps, you can run them on a lot of historical data to see if you need additional steps and things that wouldn't be in the documentation even for a human, right?
Absolutely, and you can run this like an auditory service. If you can double check that somebody did something wrong, well, that's a really good to do it, and keep between quotes, because you don't have to pay a person to do all of that. So yeah. Okay, so this validation is done in the code, in this validation router call. Just don't go hyper deep into that. Just want to show how it works in the end, because I have only 20 minutes. So when you are in the app and you do this, well, for example, in this case, we are looking at this what was the statement of work? Because that's probably what I want to show. Oh no, this one, the demo fails just at the right moment.
We're gonna be all right.
Yeah, it's strange why I have to check why this takes longer. Sometimes it's immediate, sometimes it takes longer. I don't know why. Okay. Okay. So I don't remember now which one was the one I found that had that has not been processed, this one. So as I mentioned, this no, this doesn't have an associated. Give me a second. Yeah. So this one, as you can see, there are some milestones, something. And if you click here and run a manual validation, the code is already changed. So it tries to do this, run this prompt against the data, and it's going to produce the analysis result. So
and where's it pulling that prompt from? Is that pulling it just straight out of the text file off disk, or is the prompt
exactly? This text file is part of the application at the moment, but well, you can imagine that this can be configured outside in a different place and put even a just UI on top of that. So it says, okay, it failed. So why it failed? So it shows all the validation summary. It looks that the number matches. The budget is correct. The amount is correct. Then all the details are there. And then it found something, that we didn't provide milestone data, so we cannot verify which steps were accomplished or no. So, and it says the issue, critical information such as milestone details and deliverables are missing. So it's something missing. So we have to recontact our vendors and say, hey, this is not enough, and it failed. So I'm glad that it failed because you never know. No, I'm kidding. So this is how it works. I'm going to jump to the second part of the solution because we only have 15 minutes, but well, you can check that in detail there. And just going here for this. So now we're going to see the Copilot parts. Once we have these documents that self-validate, let's say, we now can and go to the second part of our pipeline. This is mostly what I show. Okay, this here, the second part. Sorry, I went too fast. Okay, so this is probably more common for people, because this data validation with AI is something that many people have not seen, but it's really good to show. But this is more like creating a chat application where we're going to chat with our data and ask, so people can ask questions like, okay, which vendor has which invoices, or this kind of natural language query kind of questions. So how do we do this? We expose this through an API. There's a chat API. We produce an embedding of the queries or the vector, and then we go to the database, we calculate the distance, and once we improve this with semantic re-ranking, that is the thing, and we compose the results. And let's not forget that we are always creating some context for everything. No, it's like what we are doing always. Let's not forget. Let's not forget that LLMs don't have memory. That's a really complicated phrase, but you always have to build a context, and building this context manually is a total pain. And that's why we use these AI frameworks like LangChain in this case, or semantic kernel in the next session. So I'm going back here. So, okay, so we are going to, okay, so let's go to Visual Studio Code, it's probably easier. So we have this main class, and this main class is where we have our API. We have, for each path, we have some router that means that we have a path that's going to process. We're going to add this completions router, and I'm going to add this also. Doing this because this is the chat completions part. This is in a following step, I suppose, in the explanation, but I'm going like faster because of time. Okay, as you can see, we're enabling this new path for the chat session. Of course, we review the rack design. As I mentioned, we vectorize, we reconstruct. We are always building a more rich prompt, but this happens behind the scenes, no? So, okay, well, let's take a look at this function. Give me a second. Where is this thing? Chat functions. Okay. So we have these chat functions, and this is called find invoice validation results. Invoice validation results. And as you can see, we are going to create embeddings for the queries, and we are going to do this. You see, this is SQL, but this is an operator for vectors. So we are calculating the distance, let's say. And we are well. Okay, let's continue, and I will go. This is what we call a hybrid search, because we are using two things. We are using the matching text of the query, like if somebody asks the text equivalent, and we are also using the semantic part of the query. So this is a pretty common technique also when you do AI. You can use both. Okay, so this is good for this. Then now we are going to talk a little bit about LangChain, and this is, let's see, probably should show the code, but I don't remember if it's here. Yeah, it's the completions endpoint. Okay, so, okay, so here we are. So when we use LangChain, well, it has a framework that you have to provide with some things. No? So you have to provide an LLM, and this is cool because this abstracts the LLM itself. So you can now switch from OpenAI to, I don't know, Llama or whatever in fashion thing you want. You can also use, you set up your connection to the database, your client for the embeddings, and this prompt service is a local service that we have just to return these prompts. So this answers Aaron's question, that's where the prompts come from. Well, in the solution, they're abstracted, but they come from a file. But, well, they can be abstracted from a database or from a different place. So we have to create a system prompt that, again, we get this Copilot prompt from the solution, and I don't know. Okay, yeah, here it is, the prompt. You are intelligent Copilot that provides insights about. So you have this prompt. And and then you start the whole conversation path. You can get a session ID, so you can track who is talking. You define a connection to the database, you put the system prompt, and you catch up also. Well, this is useful to catch up the history of the conversation. Oh, so sorry if it's fast, but well, it kind of makes sense, some of the things here. I'm going to uncomment all of the things that from the following steps, just because I'm a little bit late. So, okay, so we have everything in place. And this is probably the coolest part. Well, we are going to build the agent. This is the most critical part, What do we need to build an agent? Well, we need this LLM, and we need a set of tools. We need the prompt. We already finished, and I didn't speak about these tools, and this is important to present. Well, we can have different, let's say, functions that are available for the agent to do things. So if I ask him, hey, find an invoice by ID, well, I can create a function, and this function will have this. And the way the LLM knows how this works is because we have this natural language description as part of the function. So this is oops, sorry. Oh, I have to back. Okay. So these are the tools that we expose. I expose one or two more tools than as I mentioned, because they're part of the next part. So this is how you build the agent, the life cycle of the agent. All of this is the framework we provide. So I cannot go even deeper into that, because I don't know, for me, this is at the moment magic, because I never gone deep into LangChain to understand how is it tracking state and all of the other things. Okay, so here we are. This is the file we were editing there. Maybe something probably asked here is, yeah, to uncomment the completions router in main. I already did that, and that should be good. So now we're going to test that it works. So this is the critical moment, and I have 10 minutes, so probably it's going to be more critical. Okay, let me continue, and we will test everything just after, or no? Okay, no, let's do it. Let's do it right now. Oops, just a second. Okay, so we go here, go to the run part. Here we have the different services. This is also already configured. When you clone the solution, you have this set up. So you have this API debugger part. Let's hop up. Okay, it's already running. Oops. Okay, I forgot to stop it before. Let's do this again. Wonder if it's okay. Well, should have worked before. Okay, let me stop this one, because I'm stopping all of those from the previous instances. Let's do this and start from scratch, and let's run this.
Because these are all running locally, right? So
yeah, that's the conversion. I'm trying to get everything to work locally. We will see.
and I will drop in here as well, because if you're interested in various aspects of the code, if you have GitHub Copilot, it's a great tool for exploring and understanding what the various functionalities and what the various library capabilities. For example, if you haven't used LangChain before, it'll explain in excellent detail what each chunk of code is doing here.
Exactly. It's really good explaining, and even okay. I'm going to continue just while if it works, just continue just for complete the information, even if I don't get to show everything. Okay, here what we're doing is just exposing this completions chat service, and well, we just ask the question and we have the answers, and you see also how behind the scenes, this is what LangChain produces behind the scenes. So this is the code. Yeah, and this is how it's working. I don't know if it's going to work. Okay, cool. It's working. Okay, so we have this other thing that exposes the service. We can go to completions, and we can try it out. And I forgot where to copy this in the previous step. So yeah, so this is the query we're doing. You can imagine you are the user doing the query, and you do this, and it should probably produce the result. Let's close fingers. Oops, sorry. No, I switched off the windows, but not the one I wanted. That is this one. So this is the agent executor trying to figure out things, and we have the answer, And then we have, well, it should print. This is what the LangChain saw. So, well, could be happy it worked. So we already have the chat service exposed. Obviously, we want to give an AI to this, UI, sorry, an interface. I said so many times AI that now I cannot say AI, only AI, not UI. Okay, so, well, we have only 10 minutes, I think more. I'm a little bit worried I cannot show more of the application, but just go through the rest of the steps in the lab. So you get an idea of what is next. Okay, so we add an UI to the chat. This basically reusing this Copilot Reactor component that's already exposed. That's pretty straightforward. Or maybe I will do it. Let's give it a try. Wait. So this is just exposing the chat-like interface. Then you go to the dashboard page, dashboard, and then you uncomment this. You uncomment each one, and then you should run the portal interface. Let's create a new tab here. Hope it works. And while this is working, I will go back here. Okay, so you are exposing the interface. You have now the chat. And oops, it works. So now I have the chat part here. So I can ask questions. So who are my vendors? Let's see if it works. Cross fingers.
So is this using the tools on the back end that you just
Yes,
highlighted in
exactly.
LangChain? It knows which tools it's going to go out and reach out to, and then it's bringing the results.
Exactly. No, this is using the same API service, the REST API we deployed just before, the Swagger one we tested. Now we have a UI, and then it returned me, you see, we just with natural language question, we have the results. Of course, the next step after this is just to try to improve these results. That, well, these are pretty generic for an easy question, but if we have more difficult questions, we have ways to optimize this that are part of the solution. You have the answer that we're going to see. Okay, we tested the UI, that's good. Now we can also refine the prompt. I'm not going to do that right now, but you can, because you saw the prompt that I shared before for Copilot was pretty, let's say, basic. So now we can have more things, so it refines the answer. This is, you just go to Copilot and you have to redeploy this, say, Copilot. Okay. This is the new prompt as it should be. And then what you redeploy, but I'm not going to redeploy. I just want to mention how to improve the accuracy of the queries. And as I mentioned, we have two ways to do this. One is using semantic ranking. The other one is GraphRAG. And let's not forget also that we can do this for specific questions. Like when you saw those tools that I was showing in I forgot the name, the completions, yes, one. When we set up the LangChain model, we set up some functions, and one of these functions can somehow use one of these advanced, let's say, results improvements. For example, this one is using semantic re-ranking. You see, so what it's doing is just a part of doing the normal query is going to call a function that is called semantic ranking, that is going to go and take the results, compare them with others, and improve the accuracy, producing a pair of results. So, well, this is what it's doing. It's going to Azure ML. Okay. And okay, you have to configure the endpoint. This is the function I was talking about, the semantic re-ranking function. It basically builds two pairs of the queries versus the possible results and matches to see if they are good enough or no. And you may wonder, but how is he doing it behind the scenes? Well, he's doing it using this Azure ML.invoke instruction that is going to invoke a model that is deployed in Azure ML. And it's a model that is, let's say, compatible in the logical sense with what we're trying to do. In this case, well, it's this re-ranking. It's part of the family of re-ranking models. So yeah, that's what we do with the re-ranking part. Okay, and probably not going to show this in the demo. And then, well, you can review the function. You can review that the re-ranking is working. You enable this as I did in the completions agent part. Let's say you can call this is the agent file. You test this the same way that we did before. You have to redeploy, and that's it. Now the last part is doing GraphRAG. And this is something that many people are not familiar with, is the fact that the Azure database for PostgreSQL supports graphs also. You can use this extension called Apache Age, which supports graphs. So this is how you do. You have to enable the extension the same way we enabled OpenAI extension, vector extension, all this. This is not by default, but you can easily enable it. We support it and everything, so that's not an issue. And with this, you can represent your data as a graph. And in some cases, having a graph representation allows us to do a, let's say, more optimal traversal or more relevant transversal of your data. So this is what we do here. This is the second technique I was showing in here. If we go to this, if somebody asks me, like, I want to find the unpaid invoices for a vendor using a graph query, well, this is what it looks like, the query. And as you can see, the syntax is pretty, let's say, weird for people who are not familiar with this. This is a language called Cypher. It's like an SQL, but for graphs. So you can use a query in this graph-like query syntax to give better results. In the lab, you have to export your tables into a CSV. This is what these steps are doing. Once you have the CSVs, you can see here CSV, into Azure Storage, then they are loaded again with a script as a graph database. So we are going to create this graph relation vendors related to the statements of work and with the properties here. So this is how it does. We use a library called Writer to do that, and this is the script that builds the graph database, let's say. And then you integrate this with the code that I showed before. This is how you just access with this the query, and then you compare the two rankings, and you have the results. So this was a lot, and I spoke quite fast, my excuses, but well, we didn't expect you to understand everything or do everything, because as you saw, I was running and I was not able to do it, and I know it pretty well now. But you can come back and check out some of the things I said here. You can come back to the solution and well, check what you can do more with this. If you want to go deeper, also the GraphRAG is also a publication from Microsoft. You can go deep into the details. The idea is that we put the relevance on top of a graph. That's a way to improve the results. That's probably most of it. And the last step is just redeploy your solution to Azure once it's done. So well, with that, I think we are almost covered. So if there are any questions or something else.
So I thought I'd share the resources we have here. So if you'd like to dig into this and get access to the instructions again, and also the resources, they're all up here. You can also see the Azure Database for Postgres blog. You can get free Azure Database for Postgres and try it using the ak.ms/try PostgreSQL. And if you want to reach out to us and get answers as you're going through this hands-on, you should really join the Azure AI Foundry developer community. Now we have both a Discord and a GitHub community which you can join. So you should join both of these, and you can find that at ak.ms/foundry devs. It has links to all of those kind of things. We're both on there, both on the Discord, both on the GitHub. So feel free to reach out to us anytime.
And don't hesitate to put issues also in the solution. If there is something you understand, we monitor that GitHub repo. So yeah. Okay, well, thank you, everyone. There is one more slide, I think, Aaron.
Oh, did you sorry, I skipped ahead, sorry.
Yeah, and I meant the one before that one, I think, or I don't know, the one for the next session, just to remember everyone. Well, that then there is still one session missing. Is the next session is about legal cases Copilot solution. And if you didn't catch GraphRAG today, in that session where they will go deep into GraphRAG. So yeah, that's a good pointer. So you can finish what we didn't do. Okay, thank you everyone for joining us.
Thank you very much.
Yeah.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.